This hypothetical development network either produce or inhibit spikes on a spiny beetle. The original pathway, S stimulates P stimulates I blocks K, it cannot block E, which produces spikes. If we move into the mutations, if we have a mutation of P, then S would stimulate P, but since it's not there, that's rendered useless. So we can start our network at I, but since there is no P to stimulate I, then there is no I to block K. So then K is able to block E and produce no spikes. And therefore we will have a smooth beetle rather than a spiky beetle. Next, we'll move into I mutations. In this case, if the I is mutated, S and P are rendered useless because those are only used to stimulating I. Since I is removed, then it cannot block K, and therefore K can block E and cause no spikes to be produced. For the next mutation, we have a mutation of I and E. If I is removed, then S and P, we don't need to focus on them because they're just used to stimulate I. I cannot block K, but since E is not part of the pathway anymore, it cannot be used to stimulate the production of spikes on a spiny beetle. Therefore, this again will produce no spikes on a beetle. The last mutation is the mutation of S and K. S will not stimulate P, so P cannot stimulate I to block K. However, K already is mutated so that it cannot block E, so the only part of this network we have to focus on is E. And we know that E stimulates the production of spikes. So in this case, spikes are produced. So now, why won't all cells have spikes? This could be due to mutations, as we have just covered. So that is one reason. The next reason is that spikes are not necessary for all cells. We know that all cells have the same DNA, and it's just expressed differently. So necessary for the exoskeleton in order to protect these beetles from predators. So it's not necessary for their inside organs.